In this try it exercise, we're asked to solve a system of equations by substitution. This is a little more difficult than graphing, solving by graphing in my opinion, but it is exact because we're solving algebraically. That said, there's more of a chance to make a mistake as well. In this case, we're given the equations x squared plus 9y squared equals 9. First off, we should recognize that as an ellipse. We could always check by graphing as well. And then we're given y equals 1/3 x minus 3. Now note that we could solve for y in either equation and then substitute what's in the other equation. But in this case, we already have an equation that's solved for y, so chances are we want to go that route. It would also be more complicated to solve for either variable in the first equation because they're being squared. When we take the square root, we would have to take plus or minus the square root. If we simply use y equals 1/3 x minus 3 and substitute that into the first equation, there's no extensive simplification needed. So we'll do exactly that. We have x squared plus 9, and then we have y squared, but we want to substitute what y equals in the second equation in terms of x. So 9 times 1/3 x minus 3. We're substituting what's on the other side of the equal sign from y in the second equation, which is equal to y, into our first equation. And now this still equals 9. So we'll go ahead and start to simplify by, put that squared up there, by squaring what's in our parentheses. So we end up with x squared plus 9 times 1/3 x minus 3 squared is 1/9 x squared minus 2x plus 9. Just using the FOIL method to multiply through 1/3 x minus 3 squared. And everything still equals 9. Now we can distribute the 9 and we get x squared plus 9 times 1/9 x squared is just x squared. 9 times 1/9 is 1. Minus, because it's a plus times a minus, so we end up with a minus. 9 times negative 2x is 18 or 18x minus 18x. 9 times negative 2 is negative 18. And then we have the x variable in this term as well. And then 9 times positive 9 is just 81. And again, this still equals 9. So we'll combine like terms and move everything to the right side, or to the left side of the equation rather. So x squared plus x squared is 2x squared. The only x term is minus 18x. And then 81 minus 9 is 72. And that's going to equal 0. We subtracted 9 from both sides. So now these all have a common factor of 2. Dividing out that 2, we get, or factoring out that 2 and then dividing both sides by 2, we get x squared minus 18 divided by 2 is 9x. 72 divided by 2 is 36. You might have to use some trial and error, but you'd see that it won't factor. This quadratic won't factor. And if we look at the discriminant, so b squared minus 4ac, and again we're looking at the form ax squared plus bx plus c equals 0. So b squared minus 4ac, in this case b is negative 9, so negative 9 squared minus 4 times our leading coefficient is 1, a is 1, and then c is the plus 36. Well, now this is 81 minus 4 times 36, so 81 minus 4 times 36, that's larger than 81. That's 120 plus 24 is 144. Well, that's less than 0. So since that's less than 0, since the discriminant is less than 0, b squared minus 4ac is less than 0, we know that means there's no solution. So this represents one that probably would have been a lot easier solving by graphing, because the graphs don't even touch. It's not a matter of we don't know where they touch. It's a matter of they don't touch. And we should be able to recognize just by sketching a basic graph. If we divide that first equation by 9, we get x squared over 9 plus y squared equals 1. So that means we know that we're going to go plus or minus 3 plus or minus 1. So there's the basic graph of our ellipse. And then y equals 1/3 x minus 3. That's going to have a y-intercept of -3 and an x-intercept of 9. Because if we substitute y equals 0, 1/3 x minus 3 equals 0. That's 1/3 x equals 3, which gives us x equals 9. So that's way out here. And we would see that these graphs don't intersect, which means there's no solution. Solving algebraically, we substituted y equals 1/3 x minus 3 into the first equation for y, and then simplified to get this quadratic that we found that the discriminant is less than 0, which means there is no solution.